So students, we will learn some different concept. Today we will learn about the free energy. Very important concept. Free energy. What is free energy? Free energy is equal to G is equal to H minus Ts. It is the free energy. G is the free energy. What does it mean? You have to minimize the Ts from the enthalpy. It is the free energy. Very important concept. So we cannot determine the absolute value of free energy. So we can write it like delta G is equal to delta H minus T delta S. So you are telling that what is free energy? I have already told you that free energy means G. You have to only minimize the Ts from the enthalpy. It is only like one type of energy. And it shows the spontaneity of the reaction. It is logic. It shows us the spontaneity of the reaction. Nothing is what is free energy means what you are saying. That it shows us the spontaneity of the reaction. It is logic. You guys say that what is free energy, what is spontaneous reaction. Spontaneous reaction means spontaneous reaction. Okay. And blah blah blah. But guys, I will tell you everything about the free energy. First of all, let's take a class. First of all, you know that work is one type of energy. So when I do the work on this class, like that, I am moving this class. So all the work that I have done on the class is totally converted into the kinetic energy? No. Some of the energy or work waste as a heat, which is released due to the friction between the surface and glass. So the available energy or useful energy, or we can say that the energy which is used to move this glass is equal to available energy is equal to W that I am doing the work on the system minus heat which is released. So similarly in the case of free energy, there are two types of free energy, Helmholtz free energy and Gibbs free energy. Helmholtz free energy means A is equal to U minus Ts. Or we cannot measure the absolute value, so we can write it like delta A or delta F is equal to delta U minus T delta S. Similarly, in the case of Gibbs free energy, but you have to add the plus PV or P delta V like that. Delta G is equal to U plus PV minus Ts, or we can say that delta G is equal to delta U plus P delta V minus Ts. Just remember this thing, we will discuss all about that. So why E delta V? So the chemical reactions are open system, and Helmholtz free energy used for closed system and Gibbs free energy used for open system. And open system are directly connected with the environment. So they faces the constant pressure and volume may be changed. So we have to add the work or P delta V with the U plus P delta V minus Ts. So U plus P delta V is equal to delta H. So delta G is equal to delta H minus T delta S. We also know that delta S is equal to Q upon T or delta H upon T. So T delta S is equal to Q or delta H. So we can say that T delta S is a heat. So this heat is used to increase or decrease the entropy of the reaction. So we have to minimize T delta S from delta H to get the actual energy that is released or absorbed during the reaction, and we will get delta G, which is available energy, useful energy, or the energy, actual energy that is released or absorbed during the reaction. Now you think that what is available energy, useful energy, or actual energy? I have already told you actual energy, but available energy is also a useful energy that is used to do the work. I will give you the example in later section. Let's take an example. Formation of water, 2H2 plus O2, H2H2O liquid. So first of all, you have to find the delta H for the reaction. But first of all, you have to remember that the delta H for the element or compound which are in standard state is equal to 0 kJ per mole. We have to take it as 0. So delta H for the reaction can be given as like this, and we will get the final answer of minus 285.83 kJ per mole. It is already given in reaction, but I want to show you that delta F0 is equal to delta H2O liquid, and it is equal to minus 285.83. Means the enthalpy of the reaction is equal to the enthalpy change of the liquid water. So what about the delta S for the reaction? Delta S for the reaction is equal to delta SE product minus delta SR reactant. So delta S for the reaction can be given as like this. So for 1 mole, delta S for the reaction is minus 163.6 joule Kelvin mole inverse, or minus 0.1636 kilojoule Kelvin inverse mole inverse. So what about delta G for the reaction, which is the available energy or useful energy or the energy which is actually released during the reaction. So delta G is equal to delta H minus T delta S. So we can get the delta G like this, and the final answer will be minus 237.1 kilojoule per mole. So it is the actual energy that is released during the reaction, because some of the heat which is equal to T delta S is used to increase the entropy or decrease the entropy. Here it is used to increase the entropy of the system or the reaction. So the actual energy which is released is minus 237.1 kilojoule per mole. So we have to remember that we write the delta H in the reaction, but we have to replace it with delta G, which is actual energy that is released. Now what about thermite reaction? Fe2O3 plus 2H gives us 2Fe and 2O3. So for first of all, delta H. But we have to remember that for the element or compound which are in standard state, delta H is equal to 0. So delta H for the reaction can be given as like this, and the final answer minus 851.7 kilojoule per mole. Similarly, delta S for the reaction. Delta S for the reaction can be given as delta Fp minus delta Sr. So we can get the final answer like 0.0385 kilojoule Kelvin inverse mole inverse. And to know the actual energy that is released during the thermite reaction, we have to find delta G. Delta G is equal to delta H minus T delta S. So by doing that, we will get the final answer of delta G is equal to minus 840 kilojoule per mole. Approximate value minus 840 kilojoule per mole. That is actual energy that is released during the reaction. Now you think that about this spontaneity. Delta G is negative, it shows us the spontaneous reaction. So what does it mean? It means that the reaction automatically converts the reactant to product? No. Some reactions are well known for the automatically convert the reactant to the product. But in some reaction, we have to give some energy or some heat to start the reaction. Then this process will be spontaneous. But first we have to give the heat. After giving the heat, this process will be spontaneous. So we will discuss all about the spontaneous and spontaneous in the later video. And you have to remember that the sign of delta G is totally dependent on delta H, P, and delta S. The negative sides will be determined from the delta S, P, and delta H. These three factors also determine the negative sign of delta G. But we will discuss all about this in later video. In this video, I want to show you what is free energy. What does it mean? And also remember that here I am not explaining maths, because I want to show you the meaning of free energy from in detailed way. Let's take an example from the biology. The poor heat is converted into the energy, or we can say free energy that's stored in the ATP, adenosine triphosphate. These ATP molecules are from the glycolysis and Krebs cycles, 8 from glycolysis and 30 from Krebs cycle. Total 38 ATP from what molecule of glucose. ATP is made up of adenine, ribose sugar, and 3 phosphate groups. The 2 bonds between phosphate groups are known as phosphoanhydride bonds, which are equal high energy bonds which on proton release energy or free energy, which is used to drive various cellular reactions which are non-spontaneous. When one phosphoanhydride bond breaks, it releases ADP plus pi and plus free energy or energy which is used to drive various cellular reaction, and this reaction is known as hydrolysis of ATP. Here you can see that delta S or entropy for the reaction increases. Why? Because here ATP 1 molecule and at H product side 2 molecules, means entropy increases, but we will not consider this. Why? Because according to the second law of thermodynamics, for any spontaneous reaction, delta G or free energy decreases or entropy, total entropy will be increased. Means the entropy for the system plus entropy for surrounding, total entropy will increase, not the total entropy for system or chemical reaction. Remember this. But we will consider only delta G. Delta G for this reaction is negative, and this energy which is released or actually released during the reaction is used to drive various cellular reaction. In living cell, 1 molecule of ATP release minus 7 kilojoule per mole energy or free energy, and daily we use 100 to 150 ATP. And this ATP is the source of free energy or actual energy that is used to drive various cellular reaction like free energy is also equal to the maximum work we can gain from the system like battery. So there is a simple equation to find the electrical work or electrical energy we gain from the battery. Delta G is equal to minus NFE SAT. Or for standard reaction, delta G0 is equal to minus NFE0 SAT. So here G is directly dependent on the E SAT. And this G, which is free energy, is the actual energy that we use to illuminate the dark with flashlight or for working of tabulators, TV, toys, and clocks. But we have to remember that all cells are not 100% efficient. Means whatever value we have got from the theoretical is not equal to practical value. So just remember this thing. Let's take an example of alkaline battery like Duracell. Reaction at anode and cathode can be given as like this. Then E0 cell for this is plus 1.5 watt. So delta G is equal to minus NFP0 cell is equal to minus 2,96500 into 1.5. So it is equal to minus 285.9 kilojoule per node. So it is the actual energy that we use in our daily life. But remember one thing, that it is not 100% efficient. So maybe we will use less than minus 285.9 kilojoule per mole energy or electrical work in our daily life. So it is the simple meaning of free energy. There are more things to learn, but we will discuss all about this in later video. So if you like the video, you can do this, and I will meet you in the